Hi there. So we're going to do our notes today for physical science. I'm going to do them on this YouTube video. So at any point, if you need to pause or stop or rewind to replay something, you can definitely do so. So I might go through these notes a little bit faster than what I normally do in class, just because you do have the option to pause if you need to continue to write something down. So first thing we want to do is we are going to go to the public folder, just like so. We're at the public folder. We're going to go to our chapter 19 periodic table, and we're going to pick up the homework for tonight. So just to show you what the homework is going to look like, it is a metal group table. It is a Word document, so you can choose to make these bigger or smaller. If you want to write in them, you can do so, or you can leave it as a Word document and actually type whatever information you need to type in here. So each one of these groups then we'll talk about today. So looking down the metal groups, we'll talk about alkali, alkaline, the iron triad, the coinage triad, zinc, cadmium, mercury, and the lanthanide actinide series. So for each of these columns then, you're going to put their properties down. What makes them unique about them? Don't just tell me that all of them have the same properties. Yes, they are all metals. You want to tell me what's unique about them. Their location on the periodic table, their charges, and some possible uses of the elements in each of those groups. So this is your tonight's homework. Also, if you have not done so already, there is a Dropbox already created, and the Dropbox folder for your 8th hour homework, Chapter 19, Reinforcement, Section 1, you want to go ahead and put your homework from last night in there. So we'll talk about it first thing tomorrow. All right, so first thing that we want to do, we're continuing with our Section 1 notes. So this left off right where we stopped yesterday. So we left off with talking about the alkali metals. Or I'm sorry, we left off with metallic bonding. So your class was just one slide behind. So we finished with this slide. And now we're on the alkali metals. So first thing, alkali metals, we find them in group 1 elements. They have the 1+ charge because they can give up that 1 electron in their outermost ring. These have the same properties as every metal does. They are shiny, malleable, ductile, and conduct heat and electricity. The thing that you want to put down in your table is what makes them different. So the differences that we see, they are extremely soft metals, very, very soft metals, so soft that you can literally cut them with a knife. Also, what makes them very unique, a difference with them, is that they are extremely reactive with water and oxygen, and therefore do not occur in nature. They're always going to be combined with other non-reactive elements. So the following link is a very good link to watch. If you have the option to write it down or copy and paste it into another YouTube video, it's only about 2 minutes long, but it shows each one of these alkali metals reacting with water, and it's really cool. Definitely watch that. You'll get an ooh and ah factor going on, so it's pretty cool. All right, there's our homework then. So continuing our section 1 notes. So just a sort of quick review. Now with each one of these questions, I just want you to think about if you can answer these. So in your head right now, think about what charge do all metals have? All right, so let's see if you're right here. Oops, I need my pen. So all metals have a positive charge. Where do you find metals on the periodic table? We can find the metals on the left of the stair-step line, and you colored them blue. What is special about the alkali metals? So these differences are they're very soft and they're very reactive and do not occur in nature in their elemental form. How is an ionic bond formed? Ionic bonds are formed when the electrons are given away to another element. And lastly, what type of bonding allows metals to be bent? Answer should be metallic bonding. All right, so let's get started with some uses of alkali metals. So first thing that we need potassium and sodium in order to stay healthy. Things that we need this for in our body. We need potassium and sodium for every single nerve impulse that goes through your body. So just you thinking right now about reading those words, you need sodium and potassium for that thought to travel to your brain, for your pen to travel back to your hand, and for you to actually write it down. So these two elements are extremely vital for every activity that goes on in your body. Lithium is one of the alkali metals. We use it to treat bipolar disorder. So bipolar disorder is just when people have extreme highs and extreme lows. So they give them lithium to try and balance out that extreme happy with the extreme sad that sometimes bipolar disorder people do feel. Francium, on the other hand, francium is so rare, extremely rare because it's radioactive. As soon as francium is found, it starts breaking down into other elements because it gives off particles. It is so rare that on the entire surface of the earth, think of the whole earth, only about 25 to 30 grams. So basically like the size of your hand, if the entire surface of the earth has only that much francium on it at any one time. Alrighty, alkaline earth metals. So where do we find them? Oh, if you didn't label your periodic table, you definitely want to put them on there. You can use it for your test. So these are our group 2 elements. Group 2, what charge do they have? They do have a positive 2 charge. So the 2 positive charge comes from their 2 electrons in the outermost ring. Those are the 2 electrons that they want to give away. So they're giving away 2 electrons, giving away 2 electrons to have a 2 positive charge. Alkaline earth metals, like every metal, is shiny, is malleable, and is ductile. So what makes alkaline earth metals different? Their difference. They are easily combined with other elements, so they are not found in their elemental form in nature. So these easily combine with other elements so that they're not found in their elemental form in nature. So uses of alkaline earth metals. First one, magnesium and strontium. We use both of those to make fireworks. So the bright, vibrant colors that you see of fireworks are from magnesium burning and strontium burning. Magnesium creates a very white, bright light kind of firework color. Strontium, on the other hand, creates a vibrant red. All the other colors are other elements, but those are the 2 that we're going to talk about as far as those being the alkaline earth metals. The next thing that's going to pop up, magnesium. You want to make sure to clarify. Magnesium is the only one out of these 2 that is used in cars, planes, spacecrafts. So magnesium is the word you want to associate with being used in cars, planes, spacecrafts. Magnesium is an extremely light metal. Light being it doesn't weigh as much. It's very light, but it's extremely strong. The other thing then, magnesium, again, just magnesium by itself, is what is part of the chlorophyll of plants. So chlorophyll, just to kind of give you a reminder, that's in photosynthesis. So parts of plants are made with magnesium. Another one of the alkaline earth metals, calcium, sorry, clicked there, didn't mean to, is our calcium compounds. Calcium we use to make statues. So any statue that you see in the yards, like the little yard gnomes, those are statues made out of calcium. Some countertops are made out of calcium, and even chalk. So just the regular old chalk that we use to write on chalkboards is made from a calcium compound. All right, alkaline earth metals and your body. So definitely one of those from the previous page you need in your body. Which one do you think it is? Calcium, most definitely. Calcium is vital for your bone and muscle strength. So not only to move your bones and to move your muscles, you need calcium. So when your mom and dad told you, drink milk and you'll grow up to be big and strong, they weren't lying. You do need calcium for strong bones, and you do need calcium to actually make your muscles move. So if you're in the fitness industry or you're trying to build muscle, you need calcium. You have to drink your milk in order to get strong bones and muscles. Barium is another compound of the alkaline earth metals, and barium they use in x-rays. Anytime you need an x-ray of something other than bone. What I mean by soft tissue, soft tissues would be like your digestive tract, your small and large intestines. If they needed to take an x-ray of your throat and they wanted to see your esophagus, the tube that you swallow food through, they're going to have you drink a barium compound because it will then coat the whole inside of your body and the x-rays will be able to reflect off of that. Radium is another one in our alkaline earth metals that we use to treat cancer. So yes, radioactive might sound dangerous, but cancer is probably more dangerous. I think I would rather get rid of it and not worry about the radioactive elements so much. Transition elements. So these are the ones that we find in groups 3 through 12. They're in the middle of our periodic table. These occur in nature in their elemental form. That's what makes our transition elements different from just regular old metals. We find them in nature. There are three main groups that we're going to discuss dealing with the transition elements. So they are the iron triad, the coinage triad, and the zinc, cadmium, mercury. Sorry about that. Had a little tickle in my throat. All right, for the first group, the iron triad. Obviously, it includes iron. It also includes two others, so cobalt and nickel. Those are part of our iron triad. All three of these elements are used to make steel. Now, steel is a combination of these three in a certain amount. So you have to have the correct amount of iron, cobalt, and nickel to make steel the strongest possible substance that it can be. Iron is the most used of every single type of metal possible. So look at your periodic table. Everything you colored blue, all of those other metals, iron is the one that we use most often. Nickel. Nickel you can add to any metal for added strength and luster. So it not only makes it very strong, but it adds a little bit of shininess to it as well. All right, coinage triad. We make made of copper, silver, and gold. Coinage hopefully is making you think coins. Yes. These are extremely malleable elements, meaning we can pound them into sheets, and they are found in nature, so they were actually previously made to make coins. No longer do we use the silver and gold to make coins, but we do use the copper pennies. Copper is also used for electrical wires. And silver and gold are going to be used in making jewelry. So both of those things have other uses, but they're still known as the coinage triad. Last group then, we have zinc, cadmium, and mercury. So zinc and cadmium are used as protective coatings on metals. So what that means is it allows them to not rust. Zinc will allow things not to be rusty. Cadmium we use in rechargeable batteries. Mercury is very dangerous. They don't make them in thermometers anymore. They haven't made them in thermometers for a very, very long time because this is actually a poisonous compound. And if it accumulates in your body, it can cause death. Not a good thing. All right, inner transition metals. I'm going to put it all up here because I'm almost out of time.